let's see if we can improve on this, because we clearly can do something better than this. So I'm not a big fan of histogram graphs, but this is one of the situations where trying histograms might be a productive way of going about it. So let's do this. Make yourself a new R chunk. So we're going to still need the CI plot output at some point in the future, so go ahead and hold on to that. So I'm just going to call this histoplot, just to give it a name, and that's the assignment. So we're going to start with ggplot, and because we're making a histogram, we don't want to refer to the summary SE output. We actually want to refer back to the original data set. So for that, for me, that's the data frame DAT. So whatever your data frame name is for your raw data, that's what you need to have in here. And the code for histograms is somewhat different than the code for other types of plots. So the aesthetics statement is basically just going to be what do you want to be plotted in the histogram, which is temp. Yes? Oh yeah, see, because I suck at typing. See, the first lesson is check for typos. Thank you, Elizabeth. So you want to put your variable in there, and then you want to define what the fill is that's going to fill your histogram. Put your plus sign to take it to the next line, and then geom underscore histogram. And then at this point, there are a couple of things that you want to do in here, and I'll explain why you want to do them. The aesthetic statement is going to be, you want to do y equals, and then dot dot density dot dot, and then close the parentheses and put a comma. Basically what you're doing is you're asking it to plot density. Essentially, density is R's version of frequency. So it's going to make a frequency histogram of this based on the frequencies that are in your data. Then you want to set the bandwidth. This is how wide the width of each bin is that you, it's not bandwidth, bin width. This sets the size of the bins that it puts the data into. So if you make this wider, you get a chunkier graph with broader categories. If you make it smaller, it becomes more refined and sometimes is more smooth, but occasionally will have little spikes in it. So this is something that you usually play around with. I usually start off with something like 0.5, especially if I have a range of temperatures that's like from 15 to 50 or something like 15 to 40. And then the other thing that I always forget to do is position equals, and then in quotes, identity. And then outside of that, a comma, and then alpha, and I'll explain what these things mean in a minute, equals 0.5 as well. Check your parentheses, making sure that all of your parentheses are matched. So this parentheses here should match the beginning parentheses. And so what these lines are basically doing, it's basically saying, give me a histogram. It's going to be a frequency histogram. The bin width is going to be relatively small. Position identity places these histograms on top of one another and also enables me to make them transparent so that I can place the histograms exactly where they belong, and I can see through them so that if there's overlap between histograms, I can see that. And then alpha is what we use generally in ggplot to make things transparent. Alpha of 1 is totally non-transparent, and alpha of 0.5 is 50% transparent, and alpha of 0.25 is 25% dense, et cetera, et cetera. So as this goes down, your histogram is getting more and more transparent so that you can see the layers behind the histogram if you have things that are on top of one another. So let's see, what else do we need to do? Our X label, so we'll have let's do as much as we can here at the beginning. XLab is going to be temperature, and this is in degrees centigrade. And then, so Y label should be something like frequency. If you didn't put a Y label on here, it would just label this density. And so density in R is the same thing as frequency. This just is telling the reader that, that the frequency of observations is what is actually being plotted. Scale field discrete, it's going to allow us to change the names on things. Since population is what we are filling with, we might want to make labels that are more descriptive than gal and OKC. So we can put this in here, concatenate it, put it in quotes because that's all labels go in quotes. Oh, sorry, I messed up. You have to tell it that you're going to define labels. So put labels, then equals C, and then this is actually Edmond, Oklahoma. So in my notes, it's OKC because I just think of it as the Oklahoma City area. And then we have a common theme statement that we've already defined. And so we can just invoke that common theme statement that we've already done. If you don't already have a theme statement invoked, then don't put that theme in there.
Is it okay, like, I was just going to say, like, the theme statement is the same one that we use for, like, the rat fat?
Yeah, sure. Yep. So run that and see if it runs. If it doesn't run, try and troubleshoot it. And aha! So I have a problem. I somehow put 2 parentheses in there. Yeah, so I had a parentheses issue when I ran mine. I had evidently hit parentheses twice when I should have only hit it once. And I can call it up and see what it gave me. So when you have a histogram that looks like this, put your blue tab up. Oh, you probably want me to lower the code some, don't you? Yeah.
Is it okay for legends like off to the side?
Oh, yeah. We're going to fix that in a minute because by telling it to put in labels, that invokes it putting in a legend, and actually we're going to take that legend out, and I'll show you how to do that in a minute. Yeah. So it's telling you that your problem is here.
Mm-hmm. I don't know why.
There's a plus there. Oh, you have too many. You copied what I did. You have a parentheses issue right there. So it's not going beyond that. So remove one of those, and that means you have to remove one of those at the back. So it messed up on that line, so it didn't go to that line. So now try it. All right, let's check. Oh, you have a comma here for some reason. Commas. Now try it. There you go. Yeah. So we just checked Elizabeth's error. First thing that was a mistake was too many parentheses. The second mistake was a comma. It's a checklist. Just go down the list, check for commas that aren't in place. Yeah.
It's just telling me TH isn't bound everything.
Because you probably haven't specified a theme block yet, so just take theme out, take that out, and get rid of the plus. Now try. Yeah, so I have a common theme block in mind. Oh yeah, okay. Yeah, if you haven't designated a common theme block, a common formatting block, then it's not going to find that formatting block. Yeah. Oh, let's see. Bin width. It's bin width, not bandwidth. It's misspelling. Now try it.
Thank you.
Yeah. Now call it up. Yeah, ask for it. Histoplot. There it is. All right. For whatever reason, mine is. Oh, I know why. Mine is doing what it's doing. So you guys have your legend appearing off to the side on your plots, and you see that mine is in that lower left-hand corner. My guess is that there's something in my common theme statement. I have a theme statement for where I want the legend to be. So what I probably need to do is I need to remove that from my common theme statement, because this is a theme statement that I took from some other project. Rerun that. Then when I go back down and run histoplot, it's doing what you're doing, except that my letters are all different because I've also got formatting statements in there in terms of how big the lettering is going to be. What's the problem with this histogram? It's got temperature, it's got the two populations. What does it not have on it? Well, it doesn't have means and competence intervals. We'll get to that later. It doesn't have temperature type, and it doesn't have season. So I asked you to go and look up something overnight. What did I ask you to look up? What does faceting enable us to do? Yeah, it makes little subgraphs. And so you can divide. So this is a bunch of histograms all layered on top of one another, but you can use facet to create a set of subgraphs that will then take this data, divide out those histograms such that winter is in one column, summer is in the other column, body temperature is in one row, wall temperature is in another row, environmental temperature is in a third row, and preferred temperature is in a fourth row. And then in each of these figures, there will just be two histograms, one histogram for Edmond, Oklahoma, and one histogram for Galveston, Texas. So how do we do that? There are a bunch of different facetings that you can do. Facet wrap, you usually do when you only have one variable, and it just wraps around until it runs out of levels. But you're wanting to use facet grid. And so let's try faceting. So we've saved this. Oh, so let me tell you another thing. We've saved this as a thing called histoplot. And the reason that I do this is that if you save something as a name, well, then you can just add more ggplot stuff to it. You know, whatever ggplot kind of code you want, because this is already a ggplot. So if we're going to add facet grid, we can just invoke that and then add facet grid to it as if we were adding facet grid to the bottom of this. Okay? So you'll see me naming things as we go along as I build up this graph. So what I want to do in this next coding block is I'm going to call up, I'm going to give myself a new name to save this as, so use the assignment operator, and this is going to be histoplot, but what we're going to do is we're going to add to histoplot some faceting. And what you want to do in this is you want to tell it what you want to be on the rows first and the column second. So everything is row column. So for me, I want temperature type to be the rows, and I want season to be the temperatures. And let's just try that by itself. Really? Oh, my bad. There's a tilde there, not a comma. Tilde. Typo. All right, that ran. See what that does to us. Blue tabs up when you have something that looks like this. Yeah, if you make yourself a common theme block, you can get rid of all that gray in the background and all that stuff. But that's why when you put in th, it didn't run, it's because you don't have a theme block. And that's fine. You can make one of those later. Everybody get that to run? No. All right, let's see. Oh, wow. All right, so what is all this up here?
That was the one I was trying to work
Okay. It looks like you have a problem. So this is your original, is this your original histogram that produced that?
on. I think it was this one.
Okay, run that again. Okay, so that worked. Why are we getting an error here? There is nothing after that. I'm gonna just do this real quick, run that again. Just hit Command Enter. You don't have to highlight the whole thing, you can run it anywhere in that line. Anywhere in that block. Nope. Run it up there. Up here. Okay, there you go. All right. Okay, so that worked. So it's still giving an error right here. Why would you be expecting a comma? There is no need for a comma anywhere in this. All right. All right, run that. Oh, we have an assignment operator here. It should be a plus. Now try it. So when you run histoplot, let me sweep. Still saying that it's expecting a comma. Why would it be expecting a comma? All right, let's do this. Let's just comment that out. And when we comment that out, we need to do that. Stop. Okay, all right, let's just do that. It's wanting a comma somewhere that it's not getting. Where does it want the comma that it's not getting? It's generating it, but it's like it's not wanting to come to an end. Okay, I don't know what happened, but it worked.
Okay.
And I still don't know what the issue is with it wanting a comma, because it shouldn't need a comma at the end of that, but you got that to print out. So, all right, so everybody's got this. Yeah.
Question, why, like, ours is showing up, it looks like in a different order than yours?
Oh, and it's because back at the beginning of my thing, I set how I want it to treat things. So my order is winter summer, and your order is summer winter, because you didn't do that, and R does things alphabetically. It doesn't really matter. The reason that I do it is because I collected the first collection in the winter and the second collection in the summer. But the only reason that I know that is because I'm the dude who collected the data. The other reason that I do it is that it just makes a little more intuitive sense to me to go from a situation where things are very different in the two populations to where things are very similar in the two populations. But you can easily do that by using this thing here that we've done in the past, factor, where you then set the levels in a particular order. When I did this the first time, I actually made a typo. I typed in OKCR, and then when I did this, I got down to running my analysis, and it wouldn't run my analysis. And it's because there is no OKCR in the data, so everything that was labeled OKC, it deleted, because I told it to put them in an order, and I gave them a variable name that doesn't exist. And so I had to go through and check to see what the problem was when I went to run the ANOVA. So I used table, and when you use table with the variable, it tells you how many observations are in each of those categories, how many observations are in Gallon, Oklahoma. What I found was that there was data in Gallon, there was no data in Oklahoma City, because I had given it the wrong name up here. So I had to go back and reload my data frame, change this to OKC instead of OKCR, and then it worked fine. So this is just my preference more than anything else. So one of the things that I'm not liking about this whole thing is that I have a gigantic legend there that is taking up a lot of space, that is preventing me from really seeing my data very well. So I'm going to go up here, and after my theme, I'm going to type in theme, and then legend dot position equals, and in quotes, none. And what that's going to do is it's going to get rid of the legend in the original histogram, and as a result, it's also going to get rid of the legend in my faceted data. Yeah. Because it's just taking up space and I'll probably tell you in the caption what the colors mean. So it just makes it more efficient with space. You can position the legend around, but there's so much stuff in the figure itself. Wherever you position the legend, chances are it's going to cover up the data somewhere, or you're going to have to make the text on it so small that it doesn't cover up the data, and then it's going to be hard to read anyway in a final production of the graph. So I got rid of my legend so that I can actually now see my data a little easier, because that legend isn't taking up space. Blue tabs up when you've got this figure. You got it, clear? Okay, all right, cool. Yep. All right, blue tabs down. So we faceted this. now we have all of the variables that we are interested in. We've got season, we've got temperature type, and we've got the two populations, Galveston and Oklahoma City. In this case, I've made Galveston red and Oklahoma City blue because we normally associate red with warm temperatures and blue with cold temperatures, so it's kind of intuitively obvious. Luckily for us, the default colors in R are red first and blue second, so it does that for us automatically. We could go in and we could tell it what colors we wanted those things to be by designating the color of the fill, etc. But right now it's just doing it for us automatically, which is nice. So now we have all three of our treatments accounted for in a faceted graph. We can work on prettying this thing up a little bit. You'll notice that the temperature types are all kind of the way we want them, but we might want to change winter and summer to make them capitalized. So let's just continue working with this. We're going to do let's make histo 3 our next plot. So use the assignment operator there. Histo 2, we want to add to it, skip that. Go back up above this. We need to create a labeling thing. So season lab is what I'm going to call it. Use the assignment operator. And what we want to do is we want to have two labels, one of which is winter and the other of which is summer. I'm putting mine winter and summer. If your order is summer and winter, you should do summer and winter. But all I'm really doing is changing the capitalization. Oops, yeah, I'm messing up. So what this is basically saying is I want to create a new vector. In the vector, the word winter with a capital W is going to replace winter with a lowercase letter. What is in the data frame as summer is now going to be summer with a capital letter. So it's just telling you to replace labels. And so run that, and you shouldn't get any error. When you type in season lab, then it should just give you winter is winter and summer is summer. Then what we can do is we can add to our histogram that we've already built labeler equals labeler where season equals season lab. So all we're doing is replacing things. Oh no, okay, all right. This is actually, so don't do that. That's a mistake because this is actually something that goes within what is essentially the aesthetics for this. So skip, cut this out, put it in front of histo 2, and then take this thing that we just added called labeler and put it in the faceting statement. I forgot that this is part of the faceting statement. And then get rid of all this down here. So we're still in histo 2. So histo 2 is basically taking the first plot that we made. When we're faceted gridding, we're basically saying we want type as the rows, season as the columns, and we want it to relabel season as the things that are in Season Lab. And when you do that, assuming that I haven't messed things up too badly, it should have changed this to now summer and winter are capitalized. Seems like a lot to do just to change capitalization, but this is what you have. Put your blue tab up when you got that change made. Yeah.
I tried to change it like you did, but is there something else you have to do? Because it didn't change. It's running, but it just doesn't change the order.
It didn't. You can't change the order. You have to change the order further back.
I went up and put it further up.
Oh, did you? Did you then run through all of the?
Mm-hmm.
So show me levels for season. Oh yeah, something didn't work. So do this thing. Okay, so those all seem to be running without any problems. Oh yeah, it seems to have done it. Okay, go down to your graphing then.
Like, do I have to start earlier?
Oh yeah, this is the winter data. This is the summer data.
Oh,
So you need to change. You need to change your labels. Yeah. So if you've gone and changed your order back in the beginning, so that such that your winter data is here and your summer data is here, just make sure that your labels match. So what you're basically telling it to do is to put the labels in a particular order, and you need to be cognizant of if you've changed the order of the data. What do we have time left? All right. So we now have this thing histo2. We've changed the labels. There are a lot of other things that we can do to pretty this thing up. But what I want to do with you now is the histograms are nice because it gives you a lot of information. It tells you, for example, that some data are more spread out than other data are. It also tells you where we expect means to be different and where we expect means to not be different. But it would be nice to have means and confidence intervals also plotted on this graph. And we can do that because we have some summary data that we've stored in the summary SE output. So hopefully you stored that as a name. So I'm going to show you how to add another data set to this particular plot. So at the end, we're going to have two different data sets plotted on the same graph. So we have, we're going to make histo3 now. This is another graph that we're going to generate. It's going to be made up of histo2, but now we're going to add things to this. And what we're going to add to this is geom underscore error bar h. This is going to be a horizontal error bar. As a result, we need to give it some more information that we don't normally give it in error bar because we've already graphed one set of data. We actually have to specify where we want ggplot to go and get the data for these error bars. And the data for this is from wherever you stored your summary SE output. So data equals, for me, it's CI plot. Then we have to give it an aesthetic statement. And in this case, we're going to have X max, just like we have Y max and Y min. X max is the temperature plus the confidence interval. X min is equal to the temperature minus the CI. But because we're doing a horizontal thing, we also have to tell it where we want the error bar to be. And so we have to give it a y coordinate, and I'm going to put the y coordinate up at 0.45. And so when you do this, this value is referring to the y-axis. So you have to look to your scale on the y-axis and say, okay, where do I want it to be relative to the y-axis? Well, I want it to be at the top here, hovering above the histograms, So I don't want it to be at 2, at point 2, because that's going to put it down in some of the histograms. I want it to be above that. So I've just chosen a value that is above the highest peak of any of these graphs. And then this thing has a width just like you would have if you were doing this with a normal error bar. And I'm choosing 0.025 simply because that kind of worked for me when I finally got it printed out. And then you want these to be colored according to the population. Then give yourself a plus. And you might want to check your parentheses to make sure that all your parentheses are matched. Then you want to give a plus because you now also want to add the mean, geom_point. And in this case, you want to do a lot of the same things. You want to tell it where the data is coming from. You want to give it an aesthetic statement. And in this case, the x value equals the temperature, because that's the average. And once again, you want to put it at the same height above the x-axis, so y is also going to be 0.45. And you are going to also want it to color it the color of the population. And you also want to give it a size for the dot, which is going to be, for me, a size 2. Then once you've run that, you're going to want to call up histo3. So run that. Error bar H. Oh, it's not width, it's height. H-E-I-G-H-T. H-E-I-G-H-T. I put width instead of height because on a normal error bar, it's width. On this one, it's height. So that was me not carrying over from one to the other. Now, what it looks like is it looks weird because you just see this gigantic dot. But here's the thing. This is not where you're probably going to take this figure. So put your blue tabs up when you got this to work. Let me make sure that you can see all that code. Yeah. Oh.
I don't know what I.
All right. So this one did. All right. So error in labeler. So you ran that and it ran fine?
Mm-hmm.
Okay. So labeler equals labeler. Season equals season. Wow. Why does it run the whole darn thing when I... Let's just not worry about that for now, so we can keep going. You don't really need to change that. We can figure that out after the fact. Let's just try this. Okay, so that's working. So now, whoa, do this. Chunk output in console. Now run histo3 again. Run histo3 and then call it up. Histo3. Now it'll pair over here. All right, good. Okay. Everybody got it? Okay, good. All right, so now I want you to do is I want you to go to export. Over here in the graphics pane, go to export, go to save as PDF. Set this at an 8.5 by 11-inch sheet of paper and set it at portrait and then just name some plot for it to put it out to. Yeah, so it's over here, right above your plot. There's a little tab called Export. Click on Export, save as a PDF, 8.5 by 11. Set it at Portrait, name it something. I'm going to just call it Histo 3 because that's what it is in my thing. And click on View Plot after saving. And when you save that, what you should get is a nice kind of publication quality plot. You can see that it has the point, it has error bars, it has all of your figures for each type of temperature. Now what you see is that the dots might look a little big to you because they're covering up the error bars in some cases. Just close that PDF. Go back and change this to size 1.5 or something and rerun it. That makes the dot smaller. Export it again. All your settings should still be saved before except for the file name, Histo3. Resave it, replace that file, and you now see that the dots are slightly smaller, but they still obscure the confidence intervals. So let's cut that back again to 1, see if that does any better. And export it again. And it's not really changing much. And it's because these dots are so big relative to the size of the graph in general. So here we have a plot. And you can tinker around with this plot over time. But essentially what it does is it gives you winter and summer, it gives you the distributions, and it gives you the mean and the confidence intervals, 95% confidence intervals, for all combinations of population, season, temperature type. The nice thing about this graph is that it makes it apparent when things are different and when things are not different. And it does that for all of these things. And because everything, the other nice thing about Facet is all of the graphs are on the same scale. So even though scale may change from one graph to another, those scales are all set commonly within Facet so that as you look down, this is wall temperature and body temperature. This is winter in Galveston, and this is winter in Galveston. And it looks like the body temperatures are slightly higher than the wall temperatures. So these guys seem to be doing some thermoregulation during the winter in Galveston because their body temperatures are higher than the temperatures on the wall right next to them. And you can do that because these are on the same scale. This dot falls outside the confidence interval of this dot. When you go back and look at your Tukey test results, those differences that you see in the Tukey's test should be easily mappable onto the differences that you see in the figure that you've created.
Then do we have to make sure we check assumptions as well?
Yes, you have to do all that stuff as well, but you know how to do that. What you didn't know how to do was this. Questions? New challenge, new skills. You can tinker with this, clean this up however you want. You can change virtually anything about this, so you can change the size of the labels in the facets. You can change the background of the facets, et cetera, et cetera. Just look online for changes to facets, and you'll find lots of ways that you can customize this.
I'm going to do my data file.
Yes, due Monday at 5. Does that still sound like a reasonable expectation? Claire's like, no, not really, but. All right, think about it for the next hour and let me know if you think that's an unreasonable expectation. Once again, due dates are kind of arbitrary at this point. I would rather that you have the time to do a good job on it than to rush it and not do a good job on it. So drop me an email. Everybody, drop me an email in the next hour and basically tell me what your thoughts are. On your tabs, what went well today, what didn't go well today. Save your work. You'll need this.